Myself P.V.DHARAANI, Assistant Professor, Department of Geology, A.D.M. College for Women, Nagapattinam. In our last session, we have seen about properties of groundwater and essential components of groundwater. Now, we are going to see about geological work of underground water. Define groundwater. What is meant by groundwater? That is, all the water occurring below the surface is termed variously as groundwater, subsurface water, or simply as groundwater. Groundwater is universally present and constantly moistens the rock within its range. Part of the water resulting from atmospheric precipitation, that is rainfall, which percolates through the soil into the rock strata, forming underground water. This percolation is possible only since the rocks forming the earth's surface do always have some opening present in them, and through them water can conveniently sink downwards. At very great depths, however, the enormous pressure of the overlying rock effectively reduces the number and extent of these openings, thereby fixing a lower limit below which underground water cannot occur. The substance occurrence of groundwater may be divided into two greater zones, that is, zone of saturation and zone of aeration. Both of these zones are separated from each other by water table. As we saw before, both of these zones is separated by a water table. It will be like a sandwich, that is, zone of aeration at the top and the water table at the center, and the zone of aeration saturation at the base. First, zone of saturation. It is that zone of rocks where all rocks are saturated with groundwater. As such, all the openings and pores are fully filled with water, and this zone, the top surface of it is called the water table or phreatic surface. Above the water table is the unsaturated or vadose zone. The phreatic zone size, color and depth may fluctuate with changes of season and during wet and dry periods. Depending on the characteristics of soil particles, their packing and porosity, the boundary of a saturated zone can be stable or unstable, exhibiting fingering patterns known as Saffman-Trailer instability. Predicting the onset of stable versus unstable drainage friends in of some importance in modeling phreatic zone boundaries. In this picture, you can see the zone of aeration and zone of saturation and the water table, and below you can see the aquifer. Above the water table and below the surface of earth, the pore spaces and other openings are only partially filled up with water that percolates through them. This is the zone of aeration, and in this zone, destructive chemical action takes place. It is the zone Van Hise has denominated the belt of weathering, in which the oxygen of the atmosphere assisted by moisture, carbonic acid, the organic acid, and locally by sulfuric acid acts on the rock and produce the manifold products of weathering. The water occurring in this zone is known as vadose water or suspended water. Factors affecting occurrence of groundwater. There are three factors, that is climate, topography, properties of rock, that is porosity, permeability, and sources of water. Climate. In arid climate, groundwater generally occurs at great depths, whereas in humid region, it occurs at shallow depth in flat areas, at less shallow depth in hilly areas, and at near the surface in the valleys. The water in the water table rises in the wet weather but sinks in dry weather. Then coming to the topography, when the surface is almost flat, the water table remains parallel to the surface. In an undulating humid region, the water table approximately follows the undulation of the surface but is less accentuated, rising under hills and flattening out under valleys, often intersecuting the valley floor so that the occupying rivers is fed. Properties of rocks. The properties of rock we have already seen in our last session, but now again we can go a recap. As we know, the materials underground, however, are heterogeneous and their hydrologic characteristics are varied. These variation control the occurrence of groundwater, which is porosity, and permeability are two most important factors of rock that controls the occurrence of groundwater to a major extent. Porosity. It refers to the percentage of interstitial spaces given in a volume of rock. Generally, the open spaces connect with each other. This is also called void spaces present in the rock. Compaction and filling of pore spaces becomes cementing medium decreases the porosity of rock. The porosity varies in different rocks on the basis of the following factors. The factors are sorting and size of grains, shape and packing of grains. Sorting and size of grain and shape and packing of grains. Coarse, rounded and uniformly graded sediments lead to high porosity compared with fine, angular and unsorted sediments. Thus, it seems likely that a boulder conglomerate would be more porous than a sandstone. Rounded particles can differ in porosity according to the way they are packed. Minimum porosity results when the spheres are offset, and maximum porosity occurs when each spherical particle is directly above the center of the other. As such, hard and compact rocks like the igneous and metamorphic ones have very little open space in them, and the porosity is usually less than 1%, whereas loose sand or gravels may have porosity to the extent of 25 to 45%. Permeability. Permeability is the ability of rock to transmit water through it. Permeability is most commonly defined as the relative ease with which water moves through the interstices of the rock. Therefore, for movement of water, the pores must be interconnected. Some sand dunes and unconsolidated gravels have a high porosity and are also permeable since the large pore spaces are interconnected. For example, muds may have high porosity, but the pore space are so small and poorly connected that water cannot move between them. A rock can be porous without being permeable, but cannot be permeable without having pores in it. Basically, rocks are divided into three types based on the degree of permeability. Permeable, the rocks which are permeable are gravels, sand, fissured sandstone, limestone, etc. Then semi-permeable, sand loams, loess, etc. Impervious, it is clay, shale, non-fissured, massive crystalline and cemented sedimentary rocks. Groundwater occurring in permeable geological formation are known as aquifers. Rocks, though porous but not permeable enough to furnish an appreciable supply of water for well or spring, are known as aquicludes. The rock which is impervious to water is known as aquifuge. Sources of groundwater. Basically, there are 5 sources of groundwater. They are meteoric water, condensational water, connate water or fossil water, juvenile water or magmatic water, and mixed source water. Meteoric water. Water formed by infiltration of atmospheric precipitation. That is, the atmospheric precipitation, the main source is rainfall. Condensational water. Source of replenishment of groundwater, particularly in deserts and semi-deserts where precipitation is scanty and there is rapid evaporation. Connate water or fossil water. Water that is entrapped in sediments at the time of deposition on lake or sea bottom. Juvenile water or magmatic water. Water which is associated with the magmatic activities within the earth crust. That is, the water which is entrapped in the igneous rocks are called juvenile water or magmatic water. Mixed source of water. Due to the complex migration, water get mixed up and thus constitute groundwater of a mixed type. Geologic action. When coming to the geologic action, there is 3 processes. First one is erosion, then deposition, then transportation. First we can see about erosion. Groundwater circulates slowly under the influence of gravity in general following the slopes of the water table. The rate of movement is very slow and vary considerably from one place to another according to the permeability of the rocks. Mechanical processes of erosion are absolutely insignificant in case of underground water. Groundwater brings about erosion mainly through chemical processes, that is, by the solution action, which is particularly effective in regions of soluble rocks like limestone, dolomite, gypsum and anhydrite, rock salt, etc. The dissolving capacity of groundwater depends on its content of carbon dioxide present in them and free oxygen as it enters the zone of aeration and increases with rise in temperature and pressure. When underground water circulates through limestone and other soluble rocks, it tends to dissolve the material along the joints and bedding planes, producing passages and chambers of all dimensions. Underground water is particularly effective in the solution of limestones and produces a distinctive landscape together with underground caves. The topography thus developed is known as karst topography, after an area of that name in northeastern Italy and northwestern Yugoslavia, where it was first investigated in detail. Karst topography features develop both above and under the ground surface. Erosional features. First we can see about lapis. The leaching action of the groundwater as it passes through the limestone region produces a highly rugged topography where the limestone is exposed at the surface. Water running across the surface gives rise to straight rounded grooves to the sharper edges in between. You can see the picture of lapis there. Sink. It is a large solution cavity, maybe several meters in diameter, open to the sky. These are also known as dewlines, sinkholes or swallow holes. Sometimes a sinkhole becomes so numerous that the sides begin to touch one another. Along such streams, there are small holes where water swirls into small openings leading to caverns. Caverns, these are interconnected subterranean cavities in limestone formed by the solution action of groundwater. These cavities are always having roofs intact. Caverns always vary considerably in size within wide limits and are sometimes of exceptionally large dimension and are commonly interlinked. The horizontal linking passages are known as galleries and the inclined and vertical ones are shaft. Transportation. When coming to the transportation process, transportation by groundwater takes place through solution activity. Sometimes the weathered materials are carried to sea or lakes through percolation process and sometimes they are added to the stream water. Deposition. The dissolved material traveling in solution are subjected to precipitation and consequent deposition due to the following factors. The factors are evaporation, loss of CO2, that is carbon dioxide, then chemical reaction, then change in physiochemical condition, that is temperature and pressure. Depositional feature, the first one is stalactite. Particularly in caverns lying above the water table, water may be seen dripping from the straight line of the crack in the ceiling of the cave. These droplets lose some of its gas by evaporation and deposit small granules of calcium carbonate at the point of evaporated drop. In due course, with subsequent deposition of calcium carbonate, it grows downwards as a icicle like pendant. These deposits hanging from the rooftop towards the floor are called stalactites. You can see the picture of stalactite. Then stalagmites. The water that drops from the end of the stalactite falls to the floor of the cave immediately beneath it, and with continued evaporation and deposition, down-shaped or conical deposits of calcium carbonate start growing upwards from the base. Such deposits are called stalagmite. Sinter and Travertine, groundwater emerging on the surface as springs or seepages form loose superficial deposits of silica and calcium carbonate. The silica deposit thus formed at or near the exit of such springs are known as siliceous sinters, whereas those formed of calcium carbonate are called travertine or calcium sinter. Geode is also a depositional feature. The deposits resulting from the groundwater often forms incrustation on the wall of the cave or fissures below the water table. Successive layers of amorphous silica thus formed differ in their color and texture are known as agate. But when crystallization is perfect, when developed crystals of quartz, etc. are found tapering towards the center of cavity as the teeth of a comb. Such deposits are known as geode, which are partially or completely filled with cavities. Concretion is also a depositional feature of underground water. These are spherical, nodular, discoid or lens-like forms and are due to concentrated solution effects of groundwater on rock substances which are rather difficultly soluble. These are deposits formed around some nucleus which differ in chemical and mineral composition from the enclosing substances. In clays and shales, the concretions are mainly calcareous, and in sandstone they may be ferruginous, that is iron, or calcareous, that is calcium. Replacement deposit. By the process of replacement, a groundwater dissolves matter present in any particular substance while depositing an equal volume of material it contains. Thus, it is some sort of a substitution on a volume or volume basis, and the new material preserves the most minute texture of the one replaced. Shells of fossils are replaced in this way. Even petrified wood is also a result of replacement deposit. Thank you.